computer. 5e, so we're graphing logs. Okay. Now, what's going on? Keeps pausing. Wait, give me 30 seconds, guys. Sorry, Caitlin, if you just tuned in then.
That's a communication then. She's done it before. To the sour.
Phone's off in the classroom, please.
I hate to see it.
All right, sorry about that, guys.
How would you tell you what's not the same?
That's good.
Vegan pasta.
Yeah.
Vegan pasta.
I'm sorry about that, Caitlin. It's the least exciting first few minutes ever. Okay, so to graph a log, did you do any log graphing last year?
Yeah.
Okay. It's when we did exponentials, we looked at a few main things. We looked at this intercept here at x equals to 0. We looked at the asymptote as well. And then we also looked at this value here. So when x is equal to 1. And then the value was e. So there was 3 main things we looked at. And it's going to kind of be a similar approach with our log graphs as well. So if we just graph, let's graph y is equal to log to the base e of x. What we get is we get a graph like this. It looks quite similar to the exponential graph, just transformed a little bit. But what we're going to look at again is the asymptote, the x-intercept, and then a value here. When x is equal to e, y will equal to 1. So again, x-intercept, asymptote, and also
y-intercept.
Not y-intercept as such, but like the y value. So this coordinate here, which is the e to 1. So x is equal to e. Now, we'll mainly look at this log graph, but there are other log graphs as well, obviously. But why it equals 1 here is just because it's the base. And remember that e is just a number, 2.78, whatever it is. So if we could swap all of these green bits here with 3, with 4, with 5. Sorry, you're having a bit of a yawn there, Phoebes.
I'm really tired.
It's 12:20.
I know.
What's going on? Matt's already worked a shift.
I would have worked.
Oh, here we go. Turning it on me. All right. So we have a few key values. They're in your textbook. But we've got f of 1. Oh, yeah, I forgot to write this here as well. Sorry. This is x is equal to 1 here. So if we have f of x is equal to log e to the x, we'll have f of 1 is equal to 0. So that's just the intercept. And then we have f of e is equal to 1, which is what we've kind of already drawn. Oh, that's just a pen. Which is what we've kind of already talked about. You can also do another one if you really want, which is f of 1 on e is equal to -1. So that's saying that there's some x value here, which is 1 over e, and that'll equal -1. But I think these two are kind of enough, to be honest. And then you've got the y-axis is the asymptote. What's the range of this function?
Real numbers.
All real numbers, perfect. So yeah. What about the, can we say something else about, actually that's too much of an open question. It's also an increasing function. So that's, as we keep going to the right, every single value goes higher and higher and higher. Okay, cool. So let's graph a few functions. That's really all we need to know. But we'll graph 1a now. So I've got y is equal to 2 log to the base e 3x. What would the asymptote be here?
-5. Y equals negative. X equals -5.
This is a 3, but the asymptote would still actually be this y-axis here.
Does it have to have a bit on the end? That would change it.
It would have to have a different number in this area here.
So 3x plus 1 or something. Wouldn't it?
Perfect, because that would be the graph shifting left and right.
Yep.
So we'll look at some of them in a second. So the asymptote would still be y-axis. Now we know that when this number that I've circled in green is equal to 1, that y will equal to 0. So our x-intercept is when y is equal to y is equal to 0, and that occurs when log e to the 3x is equal to 0, which means that 3x must equal 1. And that's from this part over here. So this bit that we highlighted up here in blue. So if 3x is equal to 1, that means x will equal to 1/3. So we know that the x-intercept will be at 1/3 here. Okay, now when will our, should we get another point just to make it a little bit easier? Because we've got the shape of the graph. We know it's going to be like this. We've got the asymptote, a point. Why don't we get one more point up here?
1.
Yeah, so what happens if we put in 1? We'll get y is equal to 2 log e to the 3. And that's just some number, isn't it?
Yeah.
So if we just wrote that there, you'd have to make sure you write 2 log to the base e, 3. But that's sufficient in my mind. Okay. Why don't we do question, we'll move on. This is a pretty short chapter in terms of like me teaching you guys. Let's look at 2G now. Right, for 2G, we've got y equal to 1 minus log to the base e, x plus 1.
With the last one, what happened to the 2 at the front?
So, great question. The 2 at the front is basically just this, it's a dilation up and down. So, if we were to say it was like this, y is equal to 2 log to the base ex. When is log to the base ex equal to 1?
When x is 0.
Not when x is 0, when x...
It's the same as e, is it?
Yeah, when perfect. So let's just say x is e here. It'll be 2 log to the base e, which will give us 2. So the 2 out the front is again just stretching it up higher and higher and higher. So if we didn't have this 2 here in 1a, this 2 here would be gone. It would just be log. Looks like luge there, but
When you're finding the intercept, you don't need to worry about putting it in.
correct. You don't need to worry about the 2. All right. So let's go through a similar sort of process. When it's x plus 1, how does the graph transform?
Moves to the left one.
Yeah, perfect. It moves to the left. What do you know about the asymptote?
Let's move left one.
So
Oh, it's
what would the asymptote be now?
it'd be x equals -1.
Right. So here's the asymptote at -1. What do we know about, so we've done our asymptote. Oh, no. Yeah, sorry. What do we know about our shifting up and down?
It's going up
Right.
1.
Great.
But it's negative, so it flips.
Yeah, awesome. Shifting up. So we're shifting up 1, and then we're also flipping. Sorry, you're faster than me. Okay, so we've got 3 things that are happening. It's moving to the left 1, it's moving up 1, and it's also flipping because of the negative. Which one of these 3 transformations do we do first? Actually, we don't even need to do them in like that. Let's just look at a few points. What will happen at x is equal to 0?
With a
Yep.
1k. Oh, don't worry about that.
No, yeah, keep going. Y is equal to 1 take.
Log a to 1,
And what's log e to the 1?
0.
Perfect. So you'll get x is equal to 0, you'll get y is equal to 1. Okay. What about x is equal to, when will log e x plus 1 equal to 1?
When will a equal to 1?
When what, sorry?
If the x is equal, when x is equal to e, take 1, isn't it?
Yeah, perfect. That's great work, Matt. So let's see what happens when x is equal to e, take 1. Well, we'll get y is equal to 1 minus log e. And then we'll go e take 1 plus 1. Those will cancel. So we'll get 1 minus log to the base e. And then that's just 1, as Matt said. So you'll get 0. So we know what e take 1, which is about 1.7-ish. You don't need to know exactly the number. Just some number down here. We know that it's going to intercept the y-axis. The x-axis. Great. So you know the asymptotes here. You know these 2 points connect. So you can kind of do the rest just from those 3 bits of information. So you've got 2 points and an asymptote. Bob's your uncle. You're all good. So you can kind of see why we spend a bit of time doing transformations, because if you know how to graph one graph, like this one up here, you can graph them all by looking at transformations. Once you've done that, like I know you've got a bit of catching up to do have a go at 2h for me, guys. And I'm just going to grab my charger whilst you have a go at that. You're using in class, Matthew.
My graph looks like
Have we go with 2H? Still going?
2H. Not right. Yeah. It's negative x.
Yeah.
Would that still put it the same?
Well, another way you can.
If it's negative, the negative x, or if it's negative log, does that still put it the same? But if they're both negative, then it goes in the other.
So a way that you could maybe approach it is, you know that 2 minus x, if it was log, if it was just log e to the x, you'd know that x has to be greater than 0. So if it's log e to the 2 minus x, you know that 2 minus x has to be greater than 0. Then you can move the x to the other side, so you know that x is less than 2. What would the asymptote be then, do you think?
X equals -2.
Well, x has to be less than 2.
Not less than -2. You're getting raised by your hand, by the way.
What was your asymptote, Phoebes?
Is your computer okay?
My computer or Matt's computer?
Well,
Stop. My video.
Very nice.
Better?
You good, bro?
Can you hear me, guys?
It went like really gross.
Is it still gross?
Not at the moment.
Okay. Well, let's carry on.
So the asymptote would have to be x equals 2.
Yeah, perfect.
what?
So we
What is
know that x is less than 2. So the asymptote would be x is equal to 2. And we know that as well. Another way we can find the asymptote is because, well, 2 minus x also can't equal 0. So x cannot equal 2. So we know the asymptote's at x equals 2, and we know that all of the x values need to be on the left-hand side of this asymptote. So what are some other values you came up with, Matt and Phoebes?
Wait.
Not much.
Well, no, not much.
Yeah.
What about when would log e to the x equal, log e to 2 minus x, when would that equal to 1?
Yeah. When it's e factor. No.
Well, what does this need to equal as a whole?
E.
Yeah.
So if 2 minus x is equal to e, which means,
E plus 2.
yeah, perfect.
Yeah.
You'd get 2 is equal to e plus x, and then you'd take e. So you'd get 2 minus e is equal to x. Two minus e, now that's like minus negative 0.7 or something like that. So we can put it here. So we've got another point here. What other points could we look at? Why don't we try and find the x-intercept?
Equals 0.
So when will this equal to 0?
If the 2 take x is equal to 1. Yeah.
Yeah, perfect. Which means we'll get it when x is equal to 1.
Yeah.
Right. So is right? Yeah. So 1 will probably be over here, I think. Oh, no. 1 is here. So you've got another point. You've got 1 and 0. So you've got these 2 points. You've got your asymptote. You're good to go. Easy. You could also find the y-intercept if you really want, guys, but I think that's enough for graphing it. How was that? Was that all right? Thumbs up, medium, really bad, or completely indifferent?
I don't really get the asymptote bit.
Okay, well, why don't we do another one and we can look at the asymptote. Let's just look at 2a. if we're only looking at the asymptote bit, I think this won't be too. What is an asymptote? Like, why do we want to find an asymptote? What does it show us about the values?
The graph never touches.
Yeah. So the graph never touches. So what that means is the graph can't take those values. Now for this graph here, what do we know about? Okay, actually let's look up at our original graph first. My computer gets laggier and laggier the longer we go because like the recording, my computer's not that strong. Okay, with this one here, what do we know about the x values? That they approach, but they never get to what value?
Why?
0. Yeah, perfect. So they can never equal 0 or anything less than 0 as well. But let's just focus on 0. So we know here that x can never equal 0. And that's our asymptote. X is equal to 0 because it never hits it. Okay, so we go back down to our 2a. What can x not equal? Or what can this not equal, I should say?
Can't equal 3.
So x can't equal 3, but before that, x minus 3 cannot equal
0.
Yeah, perfect. Which means x cannot equal 3. So that's just your asymptote, is x equals 3. What about 2b? Let's just make sure we've got our asymptotes all under wraps.
I think the negative, like the 2 take x, confuses me.
Log e x plus 3 take 2. So what was the asymptote? For the asymptote, you only care about the log function.
You don't care about this plus 2 or
Minus 2 or anything like that at the moment. You just care about this one here. So what can x? How would you go about looking at our asymptote here?
X plus 3 can't equal 0.
X plus 3 can't equal 0. Perfect. So what does that mean about x?
Negative 3.
Perfect. So our asymptote,
Negative 3. Y.
perfect. Awesome. That's all it is. Yeah, there's a few different things we need to do when we graph, but I think in isolation, like I think you know how to calculate asymptotes. Now after that. Cool. Any questions, guys?
Um,
All right. Well, that's all for 2E. Let's have a go at 2F, I think it is. That makes sense. Or 5F, sorry.
what one?
Exercise 5F, actually. So we're going to move on to another exercise. Because 5E is just basically being able to, yeah, you guys can kind of do it. If you can do that, you can do. What's going on here? All right, so 5F.
Doesn't look very nice.
You're going to hate me when I say it's not too bad. Okay. Remember when we had just like a linear equation, we had y equals like mx plus b. So we just had a straight line and there were two unknown variables, so m and b. How many bits of information did we need? Two, exactly. 2. And when we had y is equal to ax squared plus bx plus c, how many did we need?
3.
3. Yeah, so it's the same sort of thing here. So it's not really anything new. It's just getting comfortable with with like plugging in the numbers into an exponential equation and a log equation and stuff like that. A function, I should say. So we'll do a couple of examples now. Let's do question 2. All right, for question 2, we've got y is equal to a log e x plus b. And we've got well, first of all, how many variables are there do we need to find?
2. 3.
Well, we've got a and b. So we only need to find 2. And how many points do we have? Luckily, we've got 2 points. 5 and 0 and 10 and 2. Cool. So why don't we chuck this one in first, 5 and 0. So the y value is equal to 0 and we'll get a log to the base e. 5 plus b. Okay. Now, how could we solve what b is here?
Well, it's going to be the 5 plus 3 has to be equal to e.
Uh,
Oh no.
Has to equal to 1, doesn't it?
yeah, perfect. But great thinking about e and 1, because they're the interesting points. We don't care about like 63. Like that's just irrelevant. We care about e and 1 and zeros, those important ones.
B would be -4.
Perfect. Yeah, so we'll get 5 plus b equals 1. So b would equal to -4. All right, so then now we can rewrite our equation. We'll do that here. Y is equal to a log to the base e, x take 4. So you already know it. If you were to graph this, it would look like a log graph, but shifted to the right. Yes. Cool. So then let's look at our second one. We got 10 and 2. So 2 is equal to a log to the base e, 10 take 4, which is a log to the base e, 6. How would you find a here? And it might be easier than you think.
Is that what you put as power?
What was that, sorry?
Is that what you put it as a power?
You don't even need to do that. What is this equal to? Can you just chuck it into your calculator and get a number?
Yeah.
Yeah, it's just a number. I don't know what it is.
That number.
What was that, Matt?
So if it equals like, I don't know, 4, then it'd be 4A.
Yeah, exactly.
Like actually find A.
So you can just divide this off both sides. So you get 2 equals to the log to the base e. 6 is equal to a. So that means you've got y is equal to 2 over log to the base e 6 log to the base e x minus 4. It's just some number. Now, if you were to look at this as a transformation of the original graph, y is equal to log to the base e x, what would be happening here? Would it be moving up and down, left and right, or being dilated?
Asymptote would be X equals 4.
The what, sorry?
Asymptote.
Yeah, that's perfect. The asymptote would be x equals 4. Would the graph be moving left or right?
Right.
Yep, perfect. And what's happening with the y values as well?
They're being dilated.
Perfect. And by what factor?
Whoever log base e 6.
Perfect. So shifted and then also dilated by this fella here. All right. Have a go at... Well, I'll do question 1 now as well. Sorry, I don't know why I didn't do question 1 first. I'm a monster, apparently. So we're given y is equal to a e to the power x plus b. And we're given the coordinates 0, 5 and 4, 11. You need a minute or so to catch up from the last question.
I'm good.
I'm right.
You're all right? Okay, sweet. So we'll sub in 0, 5 first. And we'll get 5 is equal to a e to the 0 plus b.
0, X. That 8 is 0.1. So A plus X.
Perfect. E to the 0 is 1. So we just get 5 is equal to a plus b. Awesome. And then we can just sub in 4 and 11. So we'll get 11 is equal to a e to the 4 plus b. So what do you have now?
Okay.
Simultaneous equations. Perfect. So you've got your first equation and your second equation. So why don't we do, let's do b take a. Because we know that these b's here, they'll cancel out. So we'll get 11 take 5 is equal to a e to the 4 plus b, take a plus b. So these b's will cancel. Then we'll get a e to the 4 minus a is equal to 6. So how can we find a here?
Factorize.
Right, we'll factorize. And then now we just divide by e to the 4 plus 1. Minus 1, sorry. So you'll get a is equal to 6 over e to the 4 minus 1.
And then you sub that into prime B.
Yep. Then we'll sub into, let's do it into a. Yeah, a is probably better, I reckon. Yeah, just. So I forgot what a was. So then we'll get 5 is equal to 6 over e to the 4 minus 1 plus b. And then you'll just take this over to the left-hand side.
It barely is an answer.
Pardon?
Doesn't even look like an answer.
I know, it's gross, hey? So you get b is equal to 5 minus 6 over e to the 4 minus 1. You can simplify this a bit if you want. Yeah, let's do it. Let's simplify it. What else we got to do in isolation anyway? So you make the common denominator, then you'll expand it out. And then you'll get something like this. That's your A. That's your B. Or I've gone horribly wrong somewhere. But yeah, let's just go be confident. Okay, have a go at question. What?
You're right.
Right. Oh,
Yeah.
thank you, Phoebe. That's what I needed for today. Let's have a go at question 3 for me, guys. Question 3 should be a bit nicer. Big should there. The amount of, I wish I could throw popcorn when you yawn.
Oh, I'm just so tired.
Big day yesterday of doing nothing.
I worked, thank you.
Oh,
I'm always working.
always working.
Would have been working today, but you know.
Oh, this is why I love the year 10s. They don't give me this attitude. Even though I don't teach the year 10s. Maybe that's why I love them.
You're right.
How come in the last one, the factorizing the 5 went over the bracket?
This one here,
Yeah.
you didn't need to, but I just thought we had a lot of spare time in isolation, so we might as well. Because sometimes things cancel out and it makes it a bit nicer. Didn't really work that way, but it's also sometimes it is nice to have everything over the same denominator.
What's the second point in question 3?
Great question. Well, what 2 bits of information do you have?
Asymptote and the y-intercept.
Great. What's the asymptote of y equals e to the x?
What?
When you have y is equal to e to the x, what's the asymptote?
Oh,
Y equals 0.
What was that?
y equals 0.
Yeah, perfect. So how does this look like that?
Just go
Wow.
to B.
Move
It's been shifted up. It's been shifted up by B units. So if you look at that graph, what's the
I
asymptote?
mean, X. Wait, no, B would be 4.
B would be 4, perfect. Because it's just been translated or shifted up 4 units.
That one was much easier.
Yeah. So how did you got B is equal to 4. How did you get your A?
I subbed in the points.
Yep, you subbed in 0, 6. So you've got 6 is equal to, oh, what happened there? My computer is absolutely battling at the moment. 6 is equal to AE to the 0 plus 4.
Yeah.
And you take 4 on both sides. So 2 is equal to A.
Yep.
Awesome. So easy. Let's have a look at, what's going on here? Let's look at one more question together, guys, and that should be enough. Let's look at question 8.
Wait, for 3, A equals 2.
Yes,
Yeah.
correct. All right, so question 8, we've got y is equal to a log to the base 2, x minus b. And we know that the asymptote is x is equal to 5. And then we know we've got the point 7, 3. So Matt, maybe you can help me with the asymptote. With the log graph, what do we know that x minus b can't equal?
Y equals 0.
Can't equal to what, sorry? Yep, so x minus b cannot equal 0. But what do we also know about the asymptote here?
Moved to the right 5.
Yeah, so what do we know that x cannot equal?
X can't equal 5.
Perfect. So if x minus b cannot equal 0 and x cannot equal 5, well, you can just take b over to the other side here and you can say, well, we know x cannot equal 5 and we know x cannot equal b.
So B equals 5.
Perfect. So b is, what's happened to my screen? Yeah, so we know b is equal to 5. So we've got y is equal to a log to the base 2, x take 5. And that checks out because it looks like a log graph that's been shifted 5 units to the right. And so what's the second thing we do with this point? Or what do we do?
Sub it in.
Yeah, just sub it in. So we'll get 3 is equal to a log to the base 2, x take 5. Oh, forgot to sub in x. 7 take 5. So 7 take 5 is 2. So we've got log to the base 2, 2. And what's that equal to?
Oh, 2, 2, that's equal to 1.
Right. So we've got 3 is equal to a times 1,
So
which means 3 is equal to a. Super. So then down here we can just rewrite our graph. Awesome. Well, I think, fam, that's enough.
that's a wrap.
A wrap indeed. I'll put the homework questions up onto the document now, Google Docs. But for exercise 5E, it's going to will be questions 1 to 5. And for 5F, I haven't made any for 5F yet, but I'll put some up. Cool. I'm going to stop recording now. How do I stop recording?